Welcome to the Morningstar Institute 2022 Winter Week 6 solution video. Problem 1. Circle all even numbers in the following list. 3, 6, 9, 13, 16, 18, 25, 28, 36, 55, and 68. So let's start with 3. So 3 is odd, so we do not circle 3. 6 is even, so we circle 6. 9 is odd. And from 13 onwards, they're all two-digit numbers. And to determine whether they're even or odd, we just look at the ones-digit number. And for 13, it's 3. And since 3 is odd, 13 is odd. Now we look at 16. 16 is even because the 6 in 16 is also even. 18 is even because 8 is even. 25 is odd because the 5 in 25 is odd. 28 is even because 8 is even. 36 is even because the one digit in 36 is even. 55 is odd because 5 is odd. And 68 is even because 8 is even. So you should have circled 6, 16, 18, 28, 36, and 68. Problem 2. What is the sum of all odd numbers between 10 and 20? So let's first list them out. So they are 11, 13, 15, 17, and 19. So we should add all of them together. So a quick way to do this is we can add 11 and 19, and that's 30. And then 13 plus 17, and that's also 30. And then 15 is just in the middle. So we can do 30 plus 30 plus 15, which equals 75. Problem 3. Using two different numbers from 1, 2, 3, 4, 5, and 6, how many different two-digit even numbers can be formed? For example, using 1 and 4, we can form a two-digit even number 14. Looking at 1, 2, 3, 4, 5, 6, since it has to be even, 2, 4, and 6 has to be in the ones digit. They have to be in the ones digit so that the number is even. So for case 1, 2 is in the ones digit. So listing it from least to greatest, it's 12, 32, 42, 52, and 62. You can see that I didn't add 22. 22 is not allowed because there will be two 2s, and they have to be different numbers. So there can't be 22. And then case 2, 4 is in the ones digit number. So it's 14, 24, 34, 54, and 64. And then case 3 would be 6 is in the ones digit number. And so it's 16, 26, 36, 46, 56. And counting all of them together, each case has 5 numbers. So it's 5 plus 5 plus 5, and that should equal 15. Okay, problem 4. Write each of the following numbers as the sum of 3 consecutive odd numbers, 15, 27, and 63. For example, we can write 9 as 1 plus 3 plus 5. So we will use guess and check, and we will play around with the numbers to see which ones work. So for 15, it should be 3 plus 5 plus 7. And for 27, it should be 7 plus 9 plus 11. For 63, it should be 19 plus 21 plus 23. Day 2, problem 1. Determine whether the following two are even or odd. Okay, for number 1, it's even plus odd plus odd. So let's first look at the odd plus odd here. And odd plus odd is even. And then now it's left with 2 evens. And even plus even equals even. Odd plus odd plus odd. So odd plus odd is even. And then so it's even plus odd. And this should equal odd. Problem 2. Determine whether the following are even or odd without calculations. So for number 1, it's 2 plus 4 plus 6 plus 8 plus 10. So all of these are even. So it is even plus even plus even plus even plus even. So no matter how many evens there are, if you add them up, it will always equal even. 13 plus 18 plus 29 plus 35. So 13 is odd, 18 is even, 29 is odd, and 35 is also odd. So let's add these two odds together, and that's even. Okay, now we have odd plus even plus even. Even plus even is even, and then plus an odd, it is odd. Number 3, 11 plus 21 plus 33 plus 57. So 11 is odd, 21 is also odd, 33 is also odd, and 57 is odd. So these two odds added together is an even. These two odds added together is even, and even plus even equals an even. So you should have even, odd, and even. Problem 3. Consider the following sequence of numbers 1, 1, 2, 3, 5, 8, 13, 21, 34. Is the 20th number in the sequence even or odd? If you look closely at the sequence, it is odd, odd, even, and then it's odd, odd, even. So following this pattern, the 20th digit should be odd. Problem 4. Lawrence gives 21 apples to his 4 friends. Each friend might get different numbers of apples. Is that possible that each one gets an odd number of apples? It's asking if all of them can have odd number of apples. So it's basically asking odd plus odd plus odd plus odd equals what? So odd plus odd is even, and then these two odds added together are also even, and even plus even is even. And 21 is odd, so it is not possible. Day 3, problem 1. Lenya has a bedside table lamp. The lamp is off at the beginning. If Lenya presses the switch 13 times, is the lamp on or off? It is off at the beginning, so the pattern should be on, off, and then so on. And so on is basically the odd number, and off is the even. And since 13 is odd, then it should be on. Problem 2. If n is an odd number, which of the following are also odd? Circle all valid answers. A is n plus n, and so n plus n is odd plus odd, and this equals even. B is n plus 4, and since n is odd, then it's odd plus even, and this equals odd, so B is odd. C is n plus 4 plus 5, and n is odd, so odd plus even plus odd, and this should equal even. D is n plus 7, and that's odd plus odd, that should equal even. and E is n plus n plus n plus 2, and that's odd plus odd plus odd plus even, and that should equal odd. So you should have circled B and E. There are M candies on the table. A number of kids come and each take 2 candies. There are 3 candies left. Is M an even number or an odd number? So there are a number of kids that come out and take 2 candies each. And so 2 plus 2 plus 2 plus ... plus 2. And this is a number of kids. And then plus a 3. And so that should equal M. And since no matter how many evens there are, it will always still equal even, then it's even plus the 3, which is the odd, and M should be odd. Problem 4. The sum of 3 consecutive odd integers is 99. What is the largest of the integers? So if 30 plus 30 plus 30 equals 90, then the 3 odd numbers should be close to 30. So if we play around with the numbers, then we can find out that 31 plus 33 plus 35 equals 99. And the largest integer is 35. A for problem 1. Daniel has 14 candies. After he gives some to his friend Jerry, he has n candies left. If n is an odd number that is less than 10, at least how many candies does Daniel give to Jerry? So Daniel has 14 candies. Then he gives some to Jerry. And there's n candies left. So if it's less than 10, then at most he has 9 left. So 14 minus 9 equals 5, and that's at least how many candy Daniel gives to Jerry. Problem 2. A is an even number and B is an odd number. Which of the following cannot be the sum of A and B? So even plus odd equals odd, and 5 is odd, 11 is odd, 22 is even, and 35 is odd, and 41 is odd. So 22 is the even number, and since even plus odd equals odd, 22 cannot be the sum of A and B. Problem 3. A equals the sum of the first 10 even numbers started from 2, and B is the sum of the first 10 odd numbers starting from 1. Find a quick way to compute A minus B. A is 2 plus 4 plus 6 plus 8 all the way till 20. And then B is 1 plus 3 plus 5 plus 7 all the way till 19. And so right here you can see that 2 minus 1 is 1, and then 4 minus 3 is also 1, and then 6 minus 5 is 1, 8 minus 7 is 1, and so on, so on. So since there are 10 numbers in total, then there should be 10 ones. So 1 plus 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 1 equals 10. Problem 4. How many even 2-digit numbers are there where the sum of the digits is 5? So for number to be even, the ones digit has to be even. So the only way for them to be even is if it's 0, 2, or 4. It can't be 6 or 8 because 6 and 8 is too big, and since the 2 digits has to add up to 5, they can't be possible. So let's start with the 0. If it's 0, then the other digit has to be 5, since 0 plus 5 equals 5. And then next, let's try 2. And the other digit has to be 3, since 2 plus 3 equals 5. And then lastly, 4. The digit has to be 1, since 1 plus 4 equals 5. A5 problem 1. Of the following numbers, which is the largest even number? So the largest number here is 31, but it is odd, so it can't be the largest even number. And the second largest is 22, and it's even, so it's D. Problem 2. N is a whole number. Which of the following must be even? So A is n plus 2, B is n plus 5, C is n plus n, D is n plus 1, and E equals n plus n. So E is the correct choice because if n is even and it's even plus even, it will also equal even. And then if it's odd plus odd, then it's also even. So E is the correct choice. Now let's look at A, B, C, D, and why they don't work. So for A, it equals n plus 2. And if n is odd, then it will equal odd. Then this will equal odd. So for example, if n is 7, then 7 plus 2 will equal 9. And for B, if n is even, then it will also equal odd. For example, if n is 4, then you do 4 plus 5, and this is 9, and sometimes it won't work. And then for C, if n is odd, n plus n, if they're odd, then it will also equal odd. For example, if n is 3, then 3 plus 3 equal 9. And then D equals n plus 1. If n is odd, then this will equal odd. For example, if n is 3, then 3 plus 1 will equal 7. And if n is even, then it will also be odd. And for example, if it's 4, then it's 4 plus 1 and equals 9. So as you can see, E is the only one that will work. Problem 3. How many different pairs mn can be formed using numbers from the list of integers 1, 2, 3, 4, 5, 6, such that m is smaller than n and n plus n is even? So for two numbers added together to be even, the numbers have to be either both even or both odd. So we can list them out. So the first one is 1, 3, and 1 plus 3 is 4, and then 1, 5, and 1 plus 5 is 6, and then 2, 4, and 2 plus 4 is 6, then 4, 6, and 4 plus 6 equals 10, and then 2, 6, and 2 plus 6 equals 8, and 3, 5, and 3 plus 5 is 8. So all of them added together are even. There are 16 students in Mrs. Lee's class on Valentine's Day. Every student gives one gift to each of his or her classmates. Is the total number of gifts in the class even or odd? Since there are 16 students and each of them gives a gift to each of his or her classmates, then it should be 15 plus 15 plus 15 all the way plus 15, and there should be 16 of them. So 15 stands for how many gifts you would get, because the other 15 students will give you a gift each. And so since there are 16 people, then you add it up 16 times, and this equals odd plus odd plus odd plus odd, and this should also be 16. And 16 odds added together should equal even.